Welcome to JS Online Tuitions. Today in mathematics we'll be looking at matrices. So matrices are used to store or display information, and we're going to use our first example to show how we can represent matrices. So for example, if we're having this and we have said that matrices are used to store or display information. And we're going to look at this example. For example, if we take a look at the MTN FAS Super League, and we're going to draw this table. So for example, if we have this table and this shows the MTN FAS Super League, and we have team here in our first column, then we have played in our second column, then we have won, then we have drawn, then we have lost, and here we have points. And I'll give examples of 5 teams. So let's take, for instance, if we have these MTN FAS Super League, and we say that our first team here we're having Power Dynamos. In Power Dynamos, if we consider the number of matches played, that's 5. And from these 5 matches, they won 4, then they had to draw 0, then they lost 1. That means that the number of points there for Power Dynamos, that's 12. Then we can say we have Musa FC. And Musa FC, if they have played 5 games also, so if they won 3, then they had to draw 1 game there, and they have to lose 1 game. That means that their number of points there is going to be 10. Then we can say we have NAPSA. And NAPSA there, if they have played 5 games, and if they have won 3 games, they have drawn 0, they have lost 2 games, that means that their points there, it's 9. Then if we have Zanaco FC, they have played 5 games there, they have won 2 games, they have drawn 2 games, then they have lost 1 game there. That means that the number of points here, we're going to say 2 multiplied by 3, that's 6, plus 2 there, it's going to have 8. So this is just an example of the MTN FAS Super League. And as you can see, we have this information. In this information, we can display it in a matrix form. And how we can display it in a matrix form, we can say that we have our M there to represent the information in the MTN FAS Super League. So we can start with this column. So we can say we have our 5 there, we have our 5, we have our 5, we have our 5. Then we can come to this column. So we have our 3, we have our 4 there. Then we have 3, 3, 2. So 3, 3, 2. Then here we have 0, 1, 0, 2. So 0, 1, 0, 2. Then here we have 1, 1, 2, 1. 1, 1, 2, 1. Then we have 12, 10, 9, 8. So 12, 10, 9, 8. And this is how we can display this information in the empty and fuzz superlig. So that can be our matrix M. So we can say that matrices is an array of numbers that shows rows and columns. So matrices is just an array of numbers that shows rows and columns. So I've said matrices is an array of numbers that shows rows and columns. And if you can understand these 2 points, if you can just understand the rows and columns, it will be easy for you to follow through this topic concerning matrices. And if we can give a general matrix in the form of, we can say this is A, B, C, D. So from this information here, we can say that we have this part and this part. So we have A, B there and C, D. So these, they represent rows. Then if we consider AC and BD there, these, they form up columns. So if you can understand just this simple point, it will be easy for you to understand matrices. And from this example that you gave for the empty and fuzz superlig, we can say that we have that, we have that, we have that, we have that. So all these, they represent rows. Then for the columns there, we have this part, we have that part, we have that part, we have that part, we have that part. So all those, they represent columns. If you can just understand these simple terms, the rows and columns, it will be easy for you to answer any questions on matrices. So we should understand that each member of an array is referred to as an element or an entry. And from this here, we can say that our A, B, C, D, these are referred to as elements or entries. So I've said each member of an array is called an element or entry. So we can now look at how you can find the order of a matrix or finding the order of a matrix. So let's now look at on how we can find the order of a matrix. So the order of a matrix is found by giving the number of rows followed by the number of columns. So the order of any matrix is found by giving the number of rows followed by the number of columns. So let us write those points on our whiteboard. So the order of the matrix is given by number of rows followed by number of columns. So this is how you can give the order of any matrix. So for example, if we have matrix A, in matrix A we have 2, 3, 4, 5. And giving the order of this matrix, we're going to give the number of rows, then followed by the number of columns. So the number of rows there, we're having 1, 2. So we're having here 1, 2. So we can say these are our rows. Then the columns, we're also having 1, 2. So we're having 1, 2. So these are our columns. So to give this order, we can say this is a 2 by 2 matrix. And this X represents by. So we can say we read X as by. So if you have an X there and you are giving it in a matrix form, that represents by. So this is a 2 by 2 matrix. Let us look at this example. Matrix B, if it's a 2, 3, 1, and giving the order there, first of all, we start by counting the number of rows. So we have 1, 2, 3. So we say 3 rows multiplied by the number of columns. We only have 1 column there. So 3 by 1 column. Let us look at the next thing. So let us now look at the row matrix. So what's the row matrix? So the row matrix is a matrix that has only 1 row. That's the row matrix. So let us now look at the column matrix. So the column matrix So the column matrix is a type of a matrix that has only 1 column. So a column matrix, it is a type of a matrix that has 1 column. And giving examples of column matrices, we can use the same one, Q. So writing this in form of a column matrix is going to be 4, 5. In this order, we can say this is a 2 by 1 matrix. Another example that we can give there, we can say matrix P there is equal to, if it is in this form, A, B, C. And we can say that the order of this matrix is a 3 by 1 matrix. So these are some of the examples of the row matrix and the column matrix. Where you have questions, please ask in the group. So let us now look at the square matrix. So the square matrix is a type of matrix where the number of rows and the number of columns are the same. In these square matrices, they have got 2 diagonals. So we have the leading diagonal and the trailing diagonal. So the leading diagonal runs from the top left to the bottom right, and the trailing diagonal runs from the bottom left to the top right. So let us look at some of the examples of the square matrices. But before we do that, let us write down some notes. So we have said the square matrix, it is a type of matrix where the number of rows is equal to number of columns. And have said the square matrix has 2 diagonals, so it has 2 diagonals. In these 2 diagonals, we have the leading diagonal and trailing diagonal. And have said the leading diagonal runs from top left to bottom right. while the trailing diagonal runs from bottom left to top right. So let us look at some of the examples of square matrices. So if we have this matrix, matrix A, and it's given in this form. So if we have 4, 2, 3, 1, and this is our matrix. So we can say 4 and 1 there. As you can see, 4 and 1, they make up the leading diagonal. Then we have 2 and 3, they form the trailing diagonal. And as you can see, this matrix, if we give this the order of this matrix, this is a 2 by 2 matrix. And we have said that a square matrix is a type of matrix where the number of rows is equal to the number of columns. So as you can see, this has 2 rows and 2 columns. Another example of a square matrix, so we can say B, if we're having 2, 3, 4, 5, 6, 7, then we have 1, 1, 2. So the order of this matrix, this is a 3 by 3 matrix. So as you can see, it has 3 rows and 3 columns. So this is a square matrix. And giving the leading diagonal, so this is going to be our leading diagonal. And for our trailing diagonal there, our trailing diagonal, those are going to be the elements. So this is going to be our trailing diagonal. Let us now look at the scalar. So when we talk about the scalar, what do you mean? So the scalar is a quantity that has size only. So when we talk about a scalar, this is just a quantity that has size only. And when you multiply a scalar with any matrix, you multiply that number or element with each and every number in that matrix. So when you multiply a scalar with any matrix, you multiply that scalar with each number or element of the matrix that you have been given. So let us look at this example. Before we look at the example, let us write down some notes. So I've said a scalar is a quantity. It's a quantity that has size only. And I've said when you multiply a scalar with any matrix, you multiply that scalar with each and every element of that matrix. So let us look at this example. So for example, we have matrix A. It's given in this form. We have 2, 3, 1, 2. And you have been told, can you find 2A? So as we can see, our 2 there represents scalar. So to find our 2A there, that means that we need to multiply 2 with each element of matrix A. So we say 2 multiplied by 2, 2 multiplied by 3, then we say 2 multiplied by 1, then also 2 multiplied by 2. So our 2A is going to be equal to 2 multiplied by 2, that's 4. Then 2 multiplied by 3, that's 6. 2 multiplied by 1, that's 2. 2 multiplied by 2, that's 4. So this is going to be our answer. Where you have questions, please ask in the group. Let us now look at equal matrices. So matrices are said to be equal if their corresponding elements are the same. So matrices are said to be equal if their corresponding elements are the same. So let us look at these examples. So for example, if we said matrix Q there, we're having 1, 2, 3, 4. And if we also say that our matrix P there is having 1, 2, 3, 4. So from this expression, we can say matrix Q is equal to matrix P, and the reason is because each element of matrix Q is equal to matrix P. So the corresponding elements of matrix Q are equal to matrix P. And we can say that these two matrices are said to be equal. So let us look at this example. So if we say our matrix A there is equal to 3y, then we have 4, then we have 2, then we have 2x, then our matrix B is equal to 9, 4, then we have 2 there, then we have 4. And if you have been told that these two matrices, matrix A and B, are said to be equal, can you calculate the variables x and y? So we know that matrices are said to be equal if their corresponding elements are the same. So here we're going to say 3y. What's the corresponding elements of 3y in matrix B there? It's 9. So say 3y is equal to 9. So to calculate y there, we're going to say divide by 3, divide by 3. So our y is equal to 3 there. That's going to be our answer. Then to calculate our 2y, so our 2x, sorry, so our 2x is equal to, so 2x correspond to 4, so 2x is equal to 4 there. So you can say divide by 2, divide by 2. Our x there is equal to 2. So we can say our y is equal to 3 and our x is equal to 2. So that's how you can calculate those variables. Let us now look at the transpose of a matrix. So to find the transpose of any matrix, you just interchange or swap the rows and the columns. So you're going to make your rows to become the columns, and you're going to make your columns to become rows. And the symbol for transpose, for example, if we are looking at matrix A there, to give the symbol of the transpose of matrix A, we can say A to the power capital letter T. So this represents transpose of A. And I've said you can find the transpose by swapping or interchanging the rows and columns. So we can say we can find the transpose by interchanging or swapping rows and columns. Let us look at this example. So if we have matrix A is equal to, so we can say A, B, C, D, and you have been told, can you find the transpose of A there? So we're going to say, to find the transpose of A, we are going to interchange the rows and columns. So we know that our first row there we have A, B. So we're going to make this to become a column. So we're going to say A, B there. And for our CD, this is our second row. So we're going to make this as our column. So C, D. So that's going to be our answer. Giving another example, if you have this matrix B, and you have been told you have 1, 2, 3, 4, 5, 6, and you have been told, can you find the transpose of B? So to find the transpose of B there, we're going to say 1, 2, 5, then 3, 4, 6, and that's going to be our answer. So where you have questions, please ask in the group. So let us now look at multiplication of matrices. So you can multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. So you can multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. So that's the simple thing that you need to know when multiplying matrices. So I've said you can multiply two matrices. So you can multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. And just giving the order of the matrices. So if you have a 2 by 2 matrix and you also have a 2 by 1 matrix, that means that you can multiply these two matrices. And the reason is because the number of columns here in the first matrix is equal to the number of rows in the second matrix. So these two parts have to be equal, and that means that the matrix that you're going to have, with the product of the matrix that you're going to have, you're going to have 2 by 1 matrix. So you're going to have 2 rows and 1 column. Let us look at another example. So if the order of the matrix is in this form, so the 3 by 1 matrix, then we also have 1 by 2. So what do we mean? We mean that we can multiply these two matrices because we have 1 column in the first matrix and we have 1 row in the second matrix. And our product there, we're going to have a 3 by 2 matrix. Giving another example, if we have a 2 by 3 column, then we also have 3 by 2 column there. That means that the number of columns there and the number of rows are the same, and our product there is going to be a 2 by 2 matrix. So that's how you can multiply two matrices. Let us now look at on how we can multiply a 2 by 2 matrix. So how we can multiply a 2 by 2 matrix. So multiplying a 2 by 2 matrix. So if we say our matrix A there is equal to A, B, C, D, then we say that our matrix B is equal to P, Q, R, S. and we have been told that we have to calculate matrix A, B there. So for us to calculate matrix A, B, first of all, you have to give the order of each matrix. So the order of matrix A there, it's a 2 by 2 matrix. So that's matrix A. What's the order of matrix B? That's a 2 by 2 matrix. So that's the first thing that you have to do. So you have to determine whether we can multiply these two matrices. And I've said you can multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. So let us identify that. We have 2 columns in the first matrix and 2 rows in the second matrix. That means that we can multiply these two matrices, and our product of a matrix there is going to be a 2 by 2 matrix. So let us do our calculations there. So we have A, B, C, D. Then we have P, Q, R, S. So how we're going to multiply this? We're going to multiply each row in the first matrix by each column in the second matrix. So we can start with A. We'll say A multiplied by P there. That's going to be AP. Then we'll say plus there B multiplied by Q. So we're going to have BQ. Then we'll continue with the first row. We're going to say A multiplied by R. So we're going to have RA plus B multiplied by S. So we're going to have BS. Then we'll say C multiplied by P. We're going to have CP plus D multiplied by Q. We're going to have DQ. Then we'll have C multiplied by R. We're going to have CR plus D multiplied by S. We're going to have DS. And this is going to be our answer. So that's how you can multiply a 2 by 2 matrix. Where you have questions, please ask in the group. So let us now look at the identity matrix. So the identity matrix is also referred to as a unit matrix. So the identity matrix is a type of matrix where the elements in the leading diagonal, they are all ones. So the elements in the leading diagonal, they are all ones. That means that all the other remaining elements are zeros. So let us write down these points. So I've said an identity matrix, it is a type of matrix where the elements in the leading diagonal are ones. Then I've said that the identity matrix is also referred to as the unit matrix. So the identity matrix is also called the unit matrix. Then the other thing that you need to know about the identity matrix is that if you multiply the identity matrix with another matrix, the answer that you're going to get, you're going to maintain the elements in the other matrix. So it's just the same as multiplying that matrix with 1. So we can say that an identity matrix can represent 1 because like the final products that you're going to get, the elements are not going to change. So what I mean is that if you multiply an identity matrix with another matrix, the product that you get in the other matrix does not change. Does not change. So this is the same as multiplying that matrix with 1. So let us look at some of the examples of the identity matrix. So the first example, we have 1, 1 there, then 0, 0. And as you can see, this is an identity matrix. And I've said an identity matrix has 1s in the leading diagonal. So as you can see, we have 1, 1 there. And we have said this part represents the leading diagonal. Then the other example that we're going to give of an identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is another example of an identity matrix. So for example, if you have been told that you have matrix A, you have 2, 1, 2, 3. Then matrix B is in form of an identity matrix, which is 1, 0, 0, 1. And you have been told, can you calculate matrix A, B? So if you can identify that matrix B represents an identity matrix, and this identity matrix can be represented as just 1. If you do your multiplication there, this matrix there, matrix A, is going to be unchanged. So our product there, we're going to have 2, 1, 2, 3. So that's going to be our answer. So continue looking at matrices. Today we're going to be looking at the zero matrix and the other components of matrices. So the zero matrix is a type of matrix where the elements are all zeros. And when you multiply a zero matrix with another matrix, the product that you're going to get is a zero matrix. So a zero matrix is a matrix where all elements are zeros. So let us write down those points. So I've said a zero matrix is a type of matrix where all the elements are zeros. And let us look at the examples of zero matrices. So examples. So the first example that we can give, it can be in the form of 0, 0, 0, 0. And giving the order of this matrix, we know this is a 2 by 2 matrix. And as you can see, we have 2 rows and 2 columns. Another example of a zero matrix can be in this form. So all the elements there are zeros, and giving the order of this matrix, this is a 2 by 1 matrix. And we can say that this is a column matrix. And the reason why this is a column matrix is because it only has one column. And I've actually said when you multiply a zero matrix with another matrix, the product that you're going to get is a zero matrix. So when you multiply a zero matrix with another matrix, the product that you get is the zero matrix. So that's all about the zero matrix. We have questions, please ask. Let us now look at on how you can multiply matrices that have got the order of 3 by 3. So let us look at multiplying. So multiplication of 3 by 3 matrices. And for this one, we're going to use this example. Let us consider that if matrix A, we're having 1, 1, 1, 2, 1, 1, then we have 1, 1, 2. Then matrix B, if we're having 1, 1, 1, then 2, 2, 1, then 2, 1, 1. And you have been told, can you find the product which is A, B? So this means that we have to multiply matrix A and matrix B. And I actually said that you can only multiply two matrices when the number of columns in the first matrix is equal to the number of rows in the second matrix. So as you can see, if we give the order of matrix A, which is our first matrix there, this is a 3 by 3 matrix, and giving the order of our second matrix of B, that's a 3 by 3 matrix. So as you can see, the number of columns in the first matrix is equal to the number of rows in the second matrix. That means that we can multiply these two matrices, and giving the product of AB there, so say AB is equal to a 3 by 3. So this is going to be the product of the matrix. So let us do the calculations there. So say AB, we'll write down first this matrix. So say 1, 1, 1, 2, 1, 1, then we have 1, 1, 2. Then we'll write down matrix B there as 1, 1, 1, 2, 2, 1, 2, 1, 1. Then when we do this, we can multiply our rows with our columns. So say AB is equal to, so say 1 multiplied by this 1. So we're going to say 1 plus. Then we'll go to our second element in our first row there. We'll say 1 multiplied by 2. So we're going to get 2 plus. Then we'll say 1 multiplied by this 2. We're going to get 2. Then we'll say 1 multiplied by 1 there. So we're getting 1 plus 1 multiplied by 2. We're getting 2 plus 1 multiplied by 1, we're getting 1. Then we'll say 1 multiplied by 1, we're getting 1, plus 1 multiplied by 1, we're getting 1, plus 1 multiplied by 1, we are getting 1. So let us go to our second row. We go to the elements in the second row. So we'll say 2 multiplied by 1, we're getting 2, plus 1 multiplied by 2, we're getting 2, plus 1 multiplied by 2, we're getting 2. So we'll continue with our elements in the second row. Then we'll go to our second column. So we'll say 2 multiplied by 1, we're getting 2, plus 1 multiplied by 2, we're getting 2, plus 1 multiplied by 1, that's 1. Then we're going to continue with our second row, and we're going to go to our third column. So I'll say 2 multiplied by 1, getting 2, plus 1 multiplied by 1, getting 1, plus 1 multiplied by 1, we're getting 1. Let us now look at our third row. So we're going to multiply our third row with these columns. So our third row there, we're going to start with the first column. So say 1 multiplied by 1, we're getting 1, plus 1 multiplied by 2, getting 2, plus 2 multiplied by 2, we're having 4. Then we'll get our third row, then we'll multiply with our second column. So say 1 multiplied by 1, getting 1, plus 1 multiplied by 2, we're getting 2, plus 2 multiplied by 1, we're getting 2. Then we say 1 multiplied by 1, we're getting 1, plus 1 multiplied by 1, we're getting 1, plus 2 multiplied by 1, we're getting 2. So we can say AB is equal to, so we can add our numbers. So 2 plus 2, that's 4, plus 1, that's 5, say 5. Then we say 1 plus 2, that's 3, plus 1, that's 4. Then we say 1 plus 1 plus 1, that's 3. Then we say 2 plus 2 plus 2, that's 6. Then we say 2 plus 2, that's 4, plus 1, that's 5. Then we say 2 plus 1 plus 1, that's 4. Then you say 4 plus 2, that's 6, plus 1, that's 7. Then we say 2 plus 2, that's 4, plus 1, that's 5. Then we say 2 plus 1 plus 1, that's 4. So that's how you can multiply matrices with the order 3 by 3. Where you have questions, please ask in the group. So let us now look at on how we can find the determinant of a 2 by 2 matrix. So the determinant of a 2 by 2 matrix is a number, and how we find this number, we subtract the product of elements of the trailing diagonal from the leading diagonal. So we are going to subtract the product of elements of the trailing diagonal from the leading diagonal. And we say that the leading diagonal runs from the top left to the bottom right. And we say that the trailing diagonal runs from the bottom left to the top right. So let us write down some points. So I've said we calculate the determinant of a 2 by 2 matrix by subtracting the product of elements of the trailing diagonal from the leading diagonal. And I said that the leading diagonal runs from the top left to the bottom right, and the trailing diagonal runs from the bottom left to the top right. So we can say that the leading diagonal runs from top left to bottom right, while the trailing diagonal runs from bottom left to top right. So if we consider finding the determinant of matrix A, so if we are calculating the determinant of matrix A, so the symbol of determinant for matrix A there is given in this form. So this is the symbol of determinant, or we can say DET dot our matrix. So this means the determinant of A. So you can either represent this or that. So let us look at an example. If we consider we have matrix A there, and this is A, B, C, D. So this is matrix A, and you have been told to calculate the determinant of matrix A. So we can say our determinant of matrix A, or we can say det dot A, and we have said that you are going to find the product of elements in the trailing diagonal, and you're going to subtract them from the product of elements in the leading diagonal. So these elements A and D, they represent the leading diagonal, and B and C represents the trailing diagonal. So to find our determinant there, we can say our A, D minus our B, C. And that's going to be our answer. So let us look at some of the examples. So our first example here, if we consider matrix B is having 2, 3, then 1, 3, and you have been told, can you find the determinant of B there? So the question is to find the determinant of B. So we're going to say the determinant of B is equal to, we're going to find the product of elements in the leading diagonal. So we're going to say 2 multiplied by 3, then minus 1 multiplied by 3. So our determinant of B there, we're going to say 2 multiplied by 3, we are going to have 6 minus 1 multiplied by 3, we're going to have 3. So the determinant of B there, 6 minus 3, we're going to have 3. So that's how you can find the determinant. Let us look at another example. So another example, we are going to say using determinant to calculate unknown value. So for example, if you have been given the determinant, then you don't know the unknown value, and we're going to give an example. For example, if we have matrix C, and this matrix C is in this form, we have K minus 1, then we have K, then we have negative 2 and 3, and you have been told the determinant of this matrix is equal to 12. So if the determinant of this matrix is equal to 12, let us find the value K. So we are finding the value K. So the first thing for us to calculate determinant, we say we're going to find the product in the leading diagonal. So we're going to say K minus 1. So multiplied by K there. Then you can put these in brackets. Minus, so we'll say 3 multiplied by negative 2. So our determinant there of C, we know that's 12, is equal to, so we'll say K multiplied by K, we're going to have K squared minus K multiplied by 1, we're going to have K minus, then we'll say 3 multiplied by negative 2, we're going to have negative 6 there. So we're going to have 12 is equals to K squared minus K, then negative multiplied by negative, we're going to have plus 6. So let us continue this side. So if we continue this side, we know we have 12 is equal to K squared minus k plus 6. So this can be written in this form: k squared minus k plus 6 is equal to 12. So we can bring our 12 to the other side. When it comes to the other side, it's going to be negative. So we're going to say k squared minus k plus 6 minus 12 is equal to, we're going to have a 0 there. Then we're going to say k squared minus k as positive 6 minus 12, we're going to have minus 6 is equal to 0. So as you can see here, we have our equation. So we can find our product sum factor for us to find the value of k. So for us to find our product there, we're going to multiply the coefficient of k squared with 6. So the coefficient of k squared, that's 1. So we're going to say 1 multiplied by negative 6. We're going to have negative 6. Then our product is the coefficient of k. And the coefficient of k, that's negative 1. So we have to find two factors. When we multiply, we're going to have negative 6. Then when we subtract, we're going to have negative 1. So those two factors, we have negative 3 and 1. Negative 3 and 2. So when we say negative 3 multiplied by 2, we're going to have negative 6. Then if we say negative 3 plus 2, we're going to have negative 1. So we can say our k squared, then we can get our negative 3k, then plus 2k minus 6 is equal to 0. So we can group our values here. Then we can find our common variable there, that's k, open brackets, k into k squared, we're going to have k minus k into 3k, we're going to have 3. Then we can say, what's common there? We can say plus 2. So 2 there, it's common. So we'll say 2 into 2k, we're going to have k. Then minus 2 into 6, we're going to have 3. It's equal to 0. So there, as you can see, these two variables are the same. So we can say k minus 3, then k plus 2 is equal to 0. So for us to find the values there, we can say k minus 3 is equal to 0, or k plus 2 is equal to 0. So we can say k is equal to, when 3 goes to the other side, it's going to be 3, or k is equal to, when 2 goes to the other side, it's going to be negative 2. So these can be the values of k. Where you have questions, please ask. Let us now look at the adjoint matrix. So you can find the adjoint of any matrix by swapping the elements in the leading diagonal and changing the signs in the trailing diagonal. So each and every matrix that you have been given, if you have been told to find the adjoint, the thing that you have to do for the leading diagonal, you just interchange or swap those elements. Then for the trailing diagonal, you change their signs. So for us to find the adjoint of any matrix, you swap or interchange elements in the leading diagonal then you change the signs in the trailing diagonal. In the symbol of adjoint, for example, if you have been told, can you find the adjoint of matrix A? So the symbol of adjoint is A, D, J. And these are small letters, then dot A. So this represents adjoint of matrix A. So if we have matrix A as A, B, C, D, and you have been told, can you find the adjoint of this matrix? So we'll say A, D, J, that's the adjoint. So the first thing that we're going to do, we are going to interchange the elements in the leading diagonal. So we are going to have D here, and we're going to have A here. Then we are going to change the signs in the trailing diagonal. So all C and B are positives, so they're going to be changed to negatives. So negative B and negative C. So this is going to be your adjoint. Let us look at another example. So another example, if we have matrix B, if we have negative 2, then 7, then here we have negative 3, then 2. And they have been told, can you find the adjoint? So we'll say A, D, J of B. So the first thing is to interchange the elements in the leading diagonal. So we are going to have 7 here, negative 2. Then we're going to change the signs in the trailing diagonal. So positive 2 is going to be negative 2. Then negative 3 is going to be positive 3. And that's going to be our answer. So that's how you can find the adjoint. Let us now look at on how we can find the inverse of a 2 by 2 matrix. So before we find the inverse of a 2 by 2 matrix, let us understand the concept inverse. So if we take the product of two elements and they can give 1, that means that those elements are inverse of one another. So this is what I mean. So if you consider that you have your x multiplied by y, and this is xy, and this gives you 1, that means that x is the inverse of y and y is the inverse of x. The other example that I can give, if we have 1 multiplied by 1 over 7, we know our answer there is 1. So that means that 1 is the inverse of 1 over 7, and 1 over 7 is the, this is supposed to be 7. So 7 multiplied by 1 over 7 is equals to 1. So we can say 7 is the inverse of 1 over 7, and 1 over 7 is the inverse of 7. So this is what we mean when we say the inverse of a 2 by 2 matrix. So if the product of two matrices, they can give an identity matrix or the unit matrix, that means that those two matrices are inverse of one another. What I mean is that if we have matrix A there multiplied by matrix B, and if this can give an identity matrix, that means that these two matrices are inverse of each other. And the identity matrix or the unit matrix, we said, can be in this form 1, 1, 0, 0. And for us to calculate the inverse of a matrix there, and the inverse of the matrix, for example, if we say, can you find the inverse of matrix A, we can say inverse of matrix A. So this is the sign of inverse. So A to the power negative 1 is equal to 1 divided by the determinant of A, then multiplied by the adjoint of matrix A. So this is the simple formula that you have to know. So the inverse of matrix A is equal to 1 divided by the determinant of matrix A multiplied by the adjoint of A. So let us look at this example. So example, we have matrix A there. We have 2, 3, then 3, 1. and they have been told, can you find the inverse of matrix A? So we're supposed to find the inverse of matrix A. So the first thing that we have to do is to calculate the determinant. And calculating the determinant there, we're going to say 2 multiplied by 3, we're going to have 6, minus 1 multiplied by 3, we're going to have 3. So the determinant there, we're going to have 6 minus 3, that's 3. Then we can write down our formula. We can say the inverse of matrix A there is 1 over determinant of A multiplied by adjoint of A. So you can say 1 divided by our determinant we have calculated as 3 there, then multiplied by the adjoint. So we said you can find the adjoint of any matrix by changing the elements in the leading diagonal. So we are going to have a 3 here, and we're going to have a 2. Then we're going to change the signs in the trailing diagonal. So we're going to have -1 there, and we're going to have -3. So finding our answer there, we can say 1 divided by 3 multiplied by 3, we're going to have 1. Then 1 divided by 3 multiplied by -1, we're going to have -1 over 3. Then 1 over 3 multiplied by -3, we're going to have -1. Then 1 over 3 multiplied by 2, we're going to have 2 over 3. So that's going to be the inverse of matrix A. So to run you through on how to calculate the inverse of any matrix, so the first thing that we're going to do is to calculate the determinant. When you find the determinant, and we have said that you can find the determinant by subtracting the product of elements of the trailing diagonal from the product of elements from the leading diagonal. When you find the determinant, then you have to calculate the adjoint. And we have said that you can calculate the adjoint of any matrix by interchanging the elements in the leading diagonal and by changing the signs in the trailing diagonal. And when you do that, you can use now this formula. That's how you can find the inverse. Where you have questions, please ask in the group. Let's continue looking at matrices, and now we're going to look at singular matrices. So singular matrices are types of matrices where the determinant is 0. And these type of matrices don't have any inverse. So a singular matrix is a type of matrix where the determinant is 0. So I've said for the singular matrix there, the determinant is 0. And these types of matrices, they don't have the inverse. They don't have an inverse. And we're going to look at these examples. So we have our first example there. Example 1, show matrix A is equal to, we have 2, 10, then 4, 5, that it is a singular matrix. So the first question reads, show that matrix A is a singular matrix. And we have said that a singular matrix is the type of matrix where the determinant is equal to 0. So if we can find the determinant of this matrix A as 0, then we're going to prove that it is a singular matrix. Then we said that for us to find determinant, we're going to use this symbol. And we say we're going to multiply the elements in the leading diagonal there. So we're going to say 2 multiplied by 10. We're going to have 20 minus. Then we're going to multiply the elements in the trailing diagonal. So 5 multiplied by 4 there, we're going to have 20. So 20 minus 20 there, we're getting 0. So as you can see, we have proved that our matrix A there is a singular matrix. Let us look at another example. So example 2. So if matrix B is singular matrix, is a singular matrix, and matrix B is given in this form. We have B minus 2, then we have P minus 2, then we have P there, then we're having 5, then we're having 3. Then you've been told find the values of P. So our second question there, it reads, if matrix P is a singular matrix, then matrix B is equal to P minus 2, then we have 3, then we have 5, then we have P. Find the values of P. So we have been told that this matrix is a singular matrix. So our first thing that we're going to do, we're going to say, for us to find the determinant of matrix B there, we're going to write down our matrix. So we have P minus 2, then we have 3, then we have 5, then we have P. And for us to calculate determinant there, we're going to multiply, we're going to find the product of elements in the trailing diagonal. Then we're going to subtract them from the product of elements in the leading diagonal. So we're going to start by multiplying the leading diagonal. So we're going to have P minus 2 there. So multiplied by P. Then minus, we're going to say 3 multiplied by 5. So the determinant there, we know that this is equal to 0, since we have been told that this matrix is a singular matrix. So we're going to say 0 is equal to P multiplied by P, we're going to have P squared. Then P multiplied by 2, we're going to have 2P. Then we're going to have our minus there. Then we're going to say 3 multiplied by 5, and we're going to have 15. So this can be written in this form as P squared minus 2P minus 15 is equal to 0. So as you can see there, we have our quadratic equation. So we can find product sum factor. So for us to find our product there, we're going to say the coefficient of P squared multiplied by negative 15. So here the coefficient of P squared, that's 1. So we're going to say 1 multiplied by negative 15. We are getting negative 15. Then the product there is the coefficient of P. And the coefficient of P there is minus 2. So there, for us to find the factors, we need to find two factors. When we multiply them, they're going to give us negative 15. Then when we add them, we're going to have negative 2. And these two factors, we can say that's going to be negative 5 and 3. So when we multiply negative 5 multiplied by 3, we're going to have negative 15. Then when we add negative 5 plus 3, we're going to have negative 2. So to simplify this, we're going to say P squared. Then we're going to get our minus 5P. Then plus 3P minus 15 is equal to 0. Then we can group this. We can group this part and that part. So there, the common element there, or the common variable there, it's P. So we can say P into P squared, that's P minus P into 5P, we're going to have 5. Then I can say plus, there our common item there is 3. So 3 into 3P, we're going to have P minus 3 into 15, we're going to have 5 is equal to 0. So as you can see here, these variables are the same that are in the brackets, so we can say p minus 5, then p plus 3 is equal to 0. And for us to find our answers there, we can say p minus 5 is equal to 0, or p plus 3 is equal to 0. So we can say p is equal to, when negative 5 goes to the other side, it's going to be positive 5, or p is equal to, when positive 3 goes to the other side of the equation, it's going to be negative 3. So the value of p can either be 5 or negative 3. So that's how you can find the singular matrices. Who have questions, please ask in the group. So let us now look at solving system of linear equations in two variables using the matrix form. And we're going to use this example on how we can calculate a linear equation with two variables using the matrix form. So let us consider that we have this question. We have 2x plus y is equal to 7. Then we also have x plus 3y is equal to 11. And they have been told, can you find the values of x and y using the matrix form? So the first thing that we are going to do here, we are going to find three matrices. So the first matrix that we are going to find, the coefficient matrix. Then the second matrix that we're going to find is the variable matrix. Then we're also going to find the constant matrix. So these three types of matrices, they're going to help us to find the solutions of x and y. So for the coefficient matrices there, we're going to be getting the figures that are in front of x and y variables. So we're going to say, to do that, we're going to say, what's the coefficient of x there? It's 2. What's the coefficient of y there? It's 1. The coefficient of x there, it's 1. Then the coefficient of y there is 3. So this is our coefficient matrix. Then coming to the next one, which is our variable matrix there. So we only have two variables. We have x and y. Then for the constant matrix there, it's going to be 7, 11. And from our matrix equation there, we can say that let A be equal to, so A is going to represent the coefficient matrix, which is 2, 1, 1, 3. Then if we say our x represents the variables or the variable matrix, which is xy, and B represents the constant matrix, which is 7, 11. So from this equation, we can say that we have our A there, and we have our B and our x there. So this is going to produce B. So we're going to say AX is equal to B. And when we multiply AX there, so let us multiply AX. So we have 2, 1, 1, 3. Then we have XY. So there we can see row by column. So when we say row by column there, we're going to say 2 multiplied by x. We're going to have 2x. Then plus 1 multiplied by y there, we're going to have y. Then we're going to say 1 multiplied by x, we're going to have x, plus 3 multiplied by y, we're going to have 3y. So this is equal to AX. So that's our AX. So for us to break this down, we know that we have our equation, which is ax is equal to b, and we want to calculate the value x there, or the variables which are in x, and we have two variables, we have x and y. So for us to do this, that means that we have to cancel out this matrix A. And how we can cancel out this matrix A? We can introduce the inverse of matrix A. So we can say the inverse of matrix A multiplied by A there. That means that we're going to cancel it out. And when we do the multiplication there, it's going to give us the identity matrix. So we have our x there is equal to, that means that even to the other side of the equation, we're going to have the inverse of A there multiplied by B. And I've said that we are introducing the inverse in our equation so that we can cancel out matrix A. And if we multiply these two, they are going to give an identity matrix, or unit matrix. And when you multiply the identity matrix with this x variable, we're going to get the x variables. So it's going to be the identity matrix. So to break this down, we're going to have x is equal to the inverse of A multiplied by B. So this is going to be the formula that we're going to use for us to find our x and y variables. So the first thing that we're going to do is to calculate the determinant of A. So we know that our A is equal to, we have 2, 1, 1, 3. So for us to calculate determinant there, we're going to say 2 multiplied by 3, we are having 6, minus 1 multiplied by 1, we're going to have 1. So the determinant of A there, we're going to have 5. That's the determinant. Since we have calculated the determinant, we have to find the inverse of matrix A. And for us to calculate inverse, we said you use this simple formula. You say 1 divided by the determinant of A multiplied by the adjoint matrix of A. So we have the inverse of A is equals to 1 divided by 5. Since our determinant is 5, so it's going to be 1 divided by 5. In the adjoint matrix there, we're going to interchange the elements in the leading diagonal. So we're going to have 3 there, we're going to have 2. Then we're going to change the signs in the trailing diagonal. We're going to have -1 and -1. So this is going to be our inverse of matrix A. So we continue this side. When say the inverse of matrix A there, it's 1 divided by 5. Then we have 3, -1, -1, 2. And I've said that for us to find our solutions, we're going to say x is equal to the inverse of matrix A multiplied by matrix B. So since we have calculated the inverse of matrix A, we can now use this equation. So we're going to say our x there is equal to the inverse of matrix A there, we're having 1 divided by 5, then 3, -1, -1, 2, multiplied by matrix B. Matrix B, we know that that's 7, 11. And we say that matrix B represents the constant matrix. So we can say our row multiplied by the column there. So x is equal to 1 over 5. So 3 multiplied by 7 there, we're going to have 20. 1 plus -1 multiplied by 11, we're going to have -11. Then -1 multiplied by 7, we're going to have -7, plus 2 multiplied by 11 there, we're going to have 22. So x is equal to 1 over 5. So we're going to say 21 minus 11, then we'll say negative 7 plus 22. So our x, I said that represents the variable matrix. In our variable matrix, we have x, y is equal to 1 over 5. So 21 minus 11, that's 10. Negative 7 plus 22, that's 15. So to find our solutions there, we can say x, y is equal to 1 over 5 multiplied by 10 there. We're going to have 2. Then 1 over 5 multiplied by 15, there we're going to have 3. So we can say our x is equal to 2 and our y is equal to 3. So that's how you can find the equation of two variables of the linear equation using matrices. So the only thing that you have to do is to use this formula. If you can know this formula, that means that you can find the linear equation with two variables using the matrix form. Where you have questions, please ask in the group. So let us now look at on how we can solve linear equations with two variables using the Cramer's rule. And for the Cramer's rule, it is important for you to know how to calculate determinant if you're going to use this part of the formula. And I've said that if you have been given a linear equation with two variables, you have to understand three matrices, or you have to find three matrices. So you have to find the coefficient matrix, you have to find the variable matrix, and you have to find the constant matrix. So we're going to use the same example that we did when we are looking at the matrix method. So the example that we had 2x plus y is equal to 7. Then we have x plus 3y is equal to 11. And I've said for you to use the Cramer's rule, you also have to understand these three things. So the first thing there is coefficient matrix, then the variable matrix, then we have the constant matrix. So you also have to understand how to calculate determinant. So our first thing that we're going to do is to find the coefficient matrix. And for us to find the coefficient matrix, we're going to look at the coefficient of the x and y variables. So the coefficient of x there, it's 2. The coefficient of x there, it's 1. The coefficient of y there, it's 1. The coefficient of y there, it's 3. So this is our coefficient matrix. And to write down the variable matrix there, the variable matrix, we only have two variables. So we're going to have x, y is equal to, then for the constant matrix there, we're going to have 7 and 11. So for us to find our x variable there, the first thing that we're going to do is to calculate the determinant of our coefficient matrix. So we're going to calculate the determinant. Determinant of the coefficient matrix. And we're going to say that determinant is going to be represented by D. So we can say for us to find our determinant there, we're going to say 2 multiplied by 3, that's 6, minus then 1 multiplied by 1, I'm going to have 1. So our D there is equals to 6 minus 1, we're going to have 5. So that's the determinant of the coefficient matrix. Then the thing that we're going to do, we're going to replace these elements. These elements, as you can see, 2 and 1, they represent the x variable. So this is the x column. So we're going to replace this x column with this constant matrix, or the constant variables. So what do I mean? So I mean that we're going to have our 7 there and our 11. They are going to replace the x column. Then we're going to maintain these elements 1, 3, and we're going to find the determinant of this matrix. And the determinant of this matrix is going to be represented as dx. So to find our dx there, we're going to say 7 multiplied by 3 there, we're going to have 21 minus 1 multiplied by 11, we're going to have 11. So our dx there, 21 minus 11, we're going to have our 10. And for us to find our x variable there, we're going to say dx, the determinant of dx there, and the determinant of d. In the determinant of d, we say that represents the coefficient matrix. So x is equal to our dx there, that's 10, divided by our determinant of the coefficient of our coefficient matrix, that's 5. So x is equals to 10 divided by 5, we are having 2. So as you can see, we have calculated our variable x as 2, so we can calculate our variable y. So we're going to say our 2x plus y is equal to 7. So I've gotten the first part of the equation there. So we know that our variable x, that's 2, so we're going to say 2 multiplied by 2 plus 7 plus y is equal to 7. So 2 multiplied by 2, that's 4, plus y is equal to 7. So we're going to say y is equal to 7 minus 4, y is equal to 3. So we can say that our answers, our x variable is equals to 2 and our y variable is equal to 3. So this is how you can find the solutions of the linear equations in 2 variables using the Cramer's rule. Where you have questions, please ask in the group. So we are done looking at the topic matrices. Where you have questions, please ask them in the group, or you can put them in the comment section. So before you go, let us go through some ECZ past papers with answers. But I just want to let you know that our online tuitions are up and running. We provide the following subjects: physics, chemistry, math, biology, and accounts. In these tuitions, they go at 100 kwacha per month, and that's per subject. We also sell some past papers with answers. We also sell some full topics videos. So if you want to check everything that I've mentioned, you want to check the prices, you want to check the subjects or the full topics videos that we are having for sale, make sure you check in the description section. So let us now look at some of the ECZ questions on matrices. So I have this first question. This first question is from 2017 paper 1, and that's 1st November, and it's on question 7. So given that matrix A is equal to 3, 2, 1, 4, 3, 0, and B is equal to 1, 2, 3, 3, 2, 1, 0, 1, 0. Find A, the transpose of matrix A, then B, we have to find AB as a single matrix. So the first thing that I'm going to do is to write down this question. So this is 2017 paper 1, and that's November. 1st November. So that's question 7. So there we been given as matrix A is 3, 2, 1, then we have 4, 3, 0. Then B we have been given as 1, 2, 3, 3, 2, 1, 0, 1, 0. Our first question requires us to find the transpose of matrix A, and we say that when we are finding the transpose of any matrix, you just interchange or you swap the rows to become the columns and the columns to become the rows. So for us to find our answer there, we're going to change these rows to become columns. So we're going to have 3, 2, 1, and we're going to change our second row there to become the column, the second column. So we're going to have 4, 3, 0. So that's going to be our answer. Let us find B. So B requires us to find matrix AB as a single matrix. And we actually said in our lesson that you can only multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. So let us write down the orders, and if we see that these two matrices are matching. So for matrix A there, the order there it's 2 by 3. Then for matrix B there, the order is 3 by 3. So as you can see, the number of columns in the first matrix is equal to the number of rows in the second matrix. That means that we can multiply these two matrices, and the product that we're going to have is going to be 2 rows and 3 columns. That's going to be our product. So we can say 3, 2, 1, 4, 3, 0, and we have 1, 2, 3, 3, 2, 1, 0, 1, 0, and a 2 by 1 matrix there. We mean that it's going to be in this form. So this is going to be a 2 by 3 matrix. It's going to be, so this is how the format of our answer is going to be. So we're going to multiply the rows and the columns there. So we're going to say 3 multiplied by 1, we're going to have 3, plus 2 multiplied by 3 there, we're going to have 6, plus 1 multiplied by 0 there, we're going to have 0. Then we're going to go to the next column. We're going to say 3 multiplied by 2, we're going to have 6, plus 2 multiplied by 4 there, we're going to have 4. 1 multiplied by 1, we're going to have plus 1. Then we're going to say 3 multiplied by 3, we're going to have 9, plus 2 multiplied by 1, we're going to have 2, plus 1 multiplied by 0, we're going to have 0. We're going to go to the elements in the second row. So we're going to say 4 multiplied by 1, we're going to have 4, plus 3 multiplied by 3, we're going to have 9, plus 0 multiplied by 0, we're going to have 0. Then 4 multiplied by 2 there, we're going to have 8, plus 3 multiplied by 2 there, we're going to have 6. Then plus 0 multiplied by 1 there, we're going to have 0. Then we're going to say 4 multiplied by 3, we're going to have 12, plus 3 multiplied by 1 there, we're going to have 1, plus 0 multiplied by 0, we're going to have 0. So we can say our AB is equal to 3 plus 6 plus 0, we're going to have 9 there. Then 6 plus 4 there, we're going to have 10 plus 1, we're going to have 11. Then 9 plus 2, we're going to have 11. Then 4 plus 9 plus 0, we're going to have 13 there. Then 8 plus 6, we're going to have 14. Okay, 12 plus 1 plus 0, but before we add this one, this is supposed to be 4 multiplied by 3, that's 12. Then 3 multiplied by 1 there, it's supposed to be 3 here. And 0 multiplied by 0 is going to be 0. So we're going to have 12 plus 3, we're going to have 15. So this is going to be our solutions. If you have questions, please ask in the group. Let us now look at the solutions for paper 2, and that was written on the 2nd of November 2017. Let us look at the question that came for matrices. So we are looking at 2017 November 2nd, and we're looking at paper 2. In that question, you can find it on the first question. In the first question reads, we have 1a, given that matrix M is equal to 3, -2, 5x, find the value of x for which the determinant of M is 22, then hence find the inverse of M. So our first thing is to calculate the value of x for which the determinant of M is 22. So let us write down that question. So we have our Roman numeral 1 there. We have been told that matrix M is equal to 3, x -2, 5. Then we have been told that the determinant of matrix M is 22, and you are required to find the value of x. Since we know the determinant as 22, we can find the value of x there. So for us to calculate determinant, we're going to multiply the elements in the leading diagonal. So we're going to say 3 multiplied by x minus -2 multiplied by 5 as elements in the trailing diagonal. So -2 multiplied by 5. So we know that our determinant of M is 22 is equal to 3 multiplied by x, that's 3x, then minus -2 multiplied by 5, I'm going to have -10. So 22 is equal to 3x. Negative multiplied by negative, we're going to have plus 10. So our 10 can go to the other side of the equation there, and we're going to have 22 minus 10 is equal to 3x. 22 minus 10 there, we're going to have 12 is equal to 3x. So divide by 3, divide by 3. So the value of x there is going to be 12 divided by 3, we're going to have 4. So that's our Roman numeral 1. So the value of x, that's 4.
Welcome to JS Online Tuitions. I hope you're doing fine. Today we're going to be looking at the answers of Mathematics Past Paper 2 of 2017. So we're going to look at section A. So we're going to start with question 1A. Question 1A reads, given that matrix M is equal to 3, negative 2, 5, x, Loma numero 1, find the value of x for which the determinant of M is 22. Loma numero 2, hence find the inverse of M. So we're going to start with Loma numero 1, find the value of x for which the determinant of M is 22. So for Loma numero 1, we are supposed to calculate the value of x for which the determinant is 22. So we are going to write down our matrix M. So we have been given that matrix M is equal to 3, negative 2, 5, x. And we have been told that the determinant of M is 22. So we have been told that our determinant of M is 22. And we have been told to calculate the value of x. So we're going to say that the determinant of M is equal to, we're going to multiply the numbers in the major diagonal minus the numbers in the minor diagonal. So what I mean is that we're going to multiply 3 and x there. Then we're also going to multiply negative 2 and 5. So we're going to say 3 multiplied by x. These are numbers in the major diagonal minus the numbers in the minor diagonal. So there we have negative 2 multiplied by 5. And the determinant of M, we have been told that is 22. So we can write down 22 there. It's equal to 3 multiplied by x, that's 3x, minus negative 2 multiplied by 5, that's negative 10. So we can say 22 is equal to 3x. Then we're going to say negative multiplied by negative, we're going to have positive there, positive 10. And when we reach this stage, we can collect the like terms. So 10 is going to go to the other side of the equation. And when it goes to the other side of the equation, it's going to become a negative. So we're going to say 22 minus 10 is equal to 3x. 22 minus 10, that's 12, is equal to 3x. So we can say 12 is equal to 3x, and to calculate the value of x there, we're going to divide both sides by 3. 3 here, 1, 3 here, 1, 3 here, 1, 3 into 12, we know that's 4. So we can say x is equal to 4. So that's our answer, x is equal to 4. Then Loma numero 2 reads, hence find the inverse of M. So for that matrix M, we can calculate the inverse since we know the value of x, which is 4. So we can say matrix M is equal to 3, then we have negative 2, then 5. Then since we have calculated the value of x as 4, we're going to write down our 4 here. And we can say that the symbol of inverse is written in this form. So that is going to be equal to 1 divided by the determinant of M, then multiplied by the matrix. When you reach this stage, you need to know something. When we started, I said that when finding the determinant, you multiply the numbers in the major diagonal, then minus the numbers in the minor diagonal. So when you're calculating the inverse there, when you're calculating the inverse, the matrix is going to change. The numbers in the major diagonal 3 and 4 there, they are going to interchange, or we're going to swap these numbers. So it means 3 will come there and 4 will come there. Then the numbers in the minor diagonal, -2 and 5, we are going to change their symbols. So let us start with the numbers in the major diagonal. So for the numbers in the major diagonal there, we are going to interchange them. So we are going to have a 4 there and we are going to have a 3 there. Then the numbers in the minor diagonal, we are going to change their symbols. So -2 there is going to be 2, then 5 is going to be -5. Then we can say the inverse of m there is equal to 1 divided by, we know that our determinant is 22. So multiplied by 4, 2, -5, 3. So that's going to be our answer. So that's going to be the inverse of matrix M. So this program has been brought to you by Joswale. If you want to get connected with me, you can actually check out my social media platforms. I'll meet you next time, and peace and God bless.